This is a reconstructed Neanderthal skeleton, and generally speaking, the skeleton is very similar to ours. Having said that, there are definite differences. The shape of all the bones is subtly different, and anywhere that muscles attach on this skeleton is much more prominent than it would be in a modern human. So this would have been a person who was much more heavily muscled, generally much more rugged looking than us today. They would have been formidable competitors. So Neanderthals were tougher and better cold adapted than us, and some of them even had bigger brains than modern humans. On the face of it then, it seems quite surprising that our species lasted very long at all. So how did we overcome the Neanderthals? Maybe our tools and weapons were just better than theirs. Well, for decades, that's exactly what the experts thought. But this idea hadn't been thoroughly tested until now. So how are you doing?
Oh, doing all right.
Bruce Bradley and Metin Erin spent over a year making thousands of basic cutting tools. So we've got these two tools. This one, a basic tool made by a Neanderthal, and this one, a basic tool made by a modern human at the same sort of period.
Correct.
Now, they're obviously very different looking. This one's long and thin, and this one is round. But are they different in terms of function, in terms of what they're used for?
They were used for the same kind of tasks, mostly cutting tasks.
So, for example, I mean, both are really sharp. If you want to use both of those to cut some pretty thick leather here.
This is a typical Neanderthal tool.
Exactly. You can see that it just cuts through this really thick leather very easily.
That is incredibly sharp. Look at that. Wow.
And this is really tough leather.
Effective, isn't it?
So,
That's brilliant.
yeah. Now let's try the blade.
Hold it very carefully.
Yes. This is the sort of thing that was made by modern humans.
Exactly.
If anything, I would say that flake is a bit, I mean, that's cutting, but just, you know, just picking up the tool and using it immediately, I'd say the flake's actually a little bit easier to use.
When we created thousands of tools, we found that the technology of the Neanderthals actually produced more cutting edge overall. It wasted less raw material, and you could produce more tools than the blade cores of modern Homo sapiens.
Now, Metin, that's very new, isn't it? That's quite remarkable, because you're telling me that the Neanderthal technology is just as good, in fact, if not better, than the modern humans. I mean, that goes against everything that people have said for the last few decades.
That's true, and it was a very exciting result.
It's just one study on one aspect of tool making. But I still think it's important. This is fascinating, and it means that the long-standing theory about modern human technology being superior to Neanderthal stone tools just doesn't stand up.
Most people from outside Africa can trace up to 4% of their DNA back to Neanderthals.
What might that Neanderthal DNA mean for us today? What sort of effects might it be having in our genomes?
Well, it's very difficult to say, but I have some results from you two which can shed some light on it. So this is a gene on chromosome 16 called WFDC1, and it's controlling cell growth. We don't know what difference it makes to have different copies of it.
So this is very early stages at the moment, but
Absolutely.
we're starting to understand the implications of having some Neanderthal genes in our genomes. And actually, we do know something about Neanderthal genes which is very interesting, and that's that we know that at least some Neanderthals had red hair, and that's very useful for Victor. So, catching up with Victor again.
Hello.
This is great. So we've actually got hair colour.
What's great about working in this nature is that it gives you the ability to test out different looks, different
Yeah.
hair and different skin color before you commit.
This is grounded in science. Okay, it's looking quite artistic, but there's science at the base of it. And also the skin colour, I see you've done really pale skin.
Yeah.
So this is somebody who lived in a northern climate.
Right, much like us.
It's really starting to come together.
Now, there's one question I want to ask is, can we tell how this individual died?
It's a great question, and usually we can't. But in this case, the skeleton gives us some really interesting clues. On the outside of your bones is a membrane, and you can see here where it's roughened, that membrane was laying down new bone at around the time that this individual died. And it's at the distal end of the tibia, it's also in the distal femora.
And the key thing about this is that it's on both sides and it's symmetrical, and actually that is pretty indicative of one particular type of disease, and it's called hypertrophic pulmonary osteoarthropathy, and it basically means
Yeah, in English, please.
okay, so it basically means you're laying down new bone, but you're doing it in such a way that we know that that's related to lung and sometimes heart disease, but it makes it very probable that this individual had either a bad lung infection or lung cancer.
Yeah. It's one of the very rare cases where we have a fossil where we can actually make some indication of the cause of death.
So from these few bones we started with, we've established that Neanderthals were strong, adaptable, and possibly had an emergent culture and budding language. They were well suited to their Ice Age home, and given they were such a successful species, they survived for 350,000 years. Yet when the crunch came, they may simply have been unlucky.
It is very sad that they're no longer with us, but we have been able to bring Laforaceae 1 back to life with the help of all of this scientific evidence and our amazing model makers.
We started with a composite skeleton based on Laforaceae 1 and other finds. And over 2 months, we've carefully been reconstructing him. With extraordinary attention to detail, the muscles were painstakingly added to rebuild his body. His face was recreated using forensic techniques. Then the skin and hair were added. Now he's finished, and he's here.
So should we go and have a look?
I can't wait.
Yeah.
This is so exciting. We have literally never seen this before. Under a sheet. Go on then, Victor. Wow.
Wow.
Oh my goodness.
Wow, his eyes sparkle.
He's really lifelike.
Yeah.
The nose is really prominent,
That is
isn't
just
it?
fantastic.
Still trying to get my head around the fact that this guy is in my ancestry and not that far back. John, what do you think?
Give me a break. You looked like twins.
Isn't he wonderful? I mean, this just looks like a living, breathing Neanderthal. I'm slightly freaked out by him, actually. I just think he's going to start moving.
That is unbelievable. It's uncanny. It's
John,
spooky.
what do you reckon?
You know, it's just got this sort of humanizing effect to put the flesh on. And it's the challenge is to make something that's different from us look different, when in
Yeah.
fact,
Yeah.
the details point to great similarity.
Oh, I can just imagine him striding off. What do you reckon? Is he muscly enough?
Yeah, he's got to be, but it's really impressive, isn't it?
It's a case where focusing on bone doesn't give the whole picture.
Yeah. Victor, such a good job. He's absolutely brilliant. Well, I'm going to be spending the night out here in the bush, presumably something our ancestors did all the time, but years of living in civilization have softened me. I've got a big torch here so that if anything comes by I can get a better look at it in the dark. And I've got this little camera so I can make a video diary throughout the night and talk about what comes along. I'm doing this for real. I'm going to be out here all night and I really am quite scared. It's just amazing the amount of noises you suddenly hear. About half an hour ago, there was the sound, really distinct sound of something lapping water. Maybe a hyena, maybe a leopard. It sounded like a big cat, literally like a cat lapping at milk. suddenly feel really vulnerable as an animal which is designed to be out in the daylight. I mean, can't see very well at night. Hearing's all right, just about enough to get you feeling scared. And sense of smell as well. Compared to all those other animals, might as well not have it. Did you hear that? I'm scared now. Is that a lion? Is that a leopard? Is that a hyena? Oh, I don't like that noise. That's really spooky. That's got to be one of the most frightening nights of my life. I did get some sleep, but then I got woken up by these horrendous noises. Sometimes it was hyenas, and then there was something that sounded like a standoff between a hyena and a leopard or something. I don't know what it was. Awful noises. Really, really scary.
With the return of the crew, I pluck up my courage and look for signs of the animals that I heard in the night.
Oh, just look at this. This is a big male leopard paw print, and there are large hyena prints as well. So these predators, these carnivores, were literally here, about 25 metres away from where I was sleeping, underneath that tree. They sounded really close during the night, and I can see now that they were.
The rib cage is not as broad or wide or flared out as some of our earlier ancestors. And so what that means is the space in between the pelvis and the diaphragm, where our guts live, seems to be a smaller volume. We have smaller guts.
Which suggests that he was eating better quality food.
The shorter the gut, the better quality of the food.
So meat could be an explanation for that, but there could be another explanation as well, why guts and teeth are getting smaller. It could have been that these guys were cooking their food.
It's controversial because until recently it was thought humans didn't control fire until around 400,000 years ago. But new chemical analysis techniques may have just put a match to all that.
Cooking with fire is a uniquely human behaviour. Today, Homo sapiens are the only species to do it, but that hasn't always been the case. In Williamstown, Massachusetts, Dr. Ann Skinner has been analysing tiny fragments of ancient animal bones that have been burned. They were found at a site used by Homo erectus, and Ann made an extraordinary discovery. Using a technique known as electron spin resonance, she can analyse changes in bone protein. These reveal what temperature the bones were burned at. Natural fires from the time of Homo erectus would have been grass fires that burn at 300 degrees Celsius. But man-made fires, created in a hearth, reach much higher temperatures.
So if I have bones that are heated above 300, and especially above 400 to give us a little leeway here, then I can be sure that they were not heated in a grass fire, and hence they have to have been heated in a fire constructed by hominids.
Anne used her technique to analyse burnt fragments of antelope bones found in Svartkrans cave in South Africa. This was a cave where Homo erectus remains had also been found. Remarkably, she found that the bones had burned at 350 degrees Celsius. Anne believes this shows they must have been burnt in a hearth.
I can show that these bones were burnt in a fire that must have been created and controlled at the cave, and that dates to somewhere between 1 and 1.5 million years, which is older than any other site that has ever been found.
Scientists believe that the only species to have the mental ability to use fire at this time was Homo erectus.
The idea that these entities had the ability to even conceive that they might control their environment, rather than just letting the environment control them. I mean, instead of seeing a burning bush and running in the other direction, to conceptually say, hey, we could use that. Even if we weren't cooking, we could use it to scare away the leopards. We could use it to keep warm. Just thinking that there's something that you could use in your environment takes more effort than you might think.
Anne's findings have rewritten the timeline on Homo erectus's ability to harness fire. Evolutionary biologist Dr. Rachel Carmody has studied the research. She believes that the early use of fire could even have accelerated their development.
This kind of work is really showing us that humans were controlling fire and were possibly using it for things like cooking very early on in human evolution.
Cooked food means a more varied, higher energy diet. This reduces the workload for the gut and leaves calories spare for the rest of the body. A fifth of the calories we consume are used to fuel our brains, and there's a theory that a switch to cooked food is one of the things that encouraged an increase in brain size.
What we see at this point in human evolution is the beginning of a trade-off, where gut size gets smaller, so you save energy by having a smaller gut. But humans seem to have been able to reallocate that saved energy toward fueling a larger brain.
So is there a link between a better diet and growing bigger brains?
I find this really intriguing and slightly unsettling, because for me, this is evolution turned on its head. Because we're saying that we are saving some energy somewhere, so that means we can grow a bit of ourselves bigger. George, what do you think?
Chimpanzee spends 47% of his time chewing and eating and processing food, whereas humans only spend 4.7. So you've got all this extra time and energy to do something with it. Why not cooking?
I'm heading along the South African coast to a place called Pinnacle Point. Today, it's a playground for the rich. But during the construction of this golf course, archaeologists discovered something amazing deep beneath the fairway. This could be the oldest known dwelling of our species anywhere in the world.
So this is where you've been digging.
This is the oldest part of the cave.
What are the dates here then as we go down through these layers?
These layers date from 130 to 167,000 years ago.
It's just so incredibly ancient.
It's amazing.
Did you know how important what you were excavating really was?
Not until we got those dates. But yeah, amazing, stunning.
The evidence in this cave reveals that those ancient families were behaving in ways quite unlike previous species of human. Well, Kyle, that's not from this cave, is it? Because I recognise this. This is a hand axe, isn't it?
That's correct. Now, that's more typical of what you would find from about 1.5 million years ago to about 300,000 years ago.
So what sort of thing were you finding in the cave then?
Okay, well, tools like these, blades and points, are much more typical of what we find in this cave. Made on quartzite, locally available on the beach down here. And in our oldest levels here, alongside these types of tools, we also have these very small bladelet tools.
These are tiny. What could such minute blades have been used for? Obviously, these weren't used just in your hand like this, so how would they have been used?
It's more likely that those were set in some kind of a handle to make a compound tool, maybe something more like this. This is a series of small blades set into a handle for use as a knife.
Yes, I think that would work. So you think that's how these stone tools were used then, as a knife?
That's one possibility. And it's also possible they would have been used for hunting weapons.
Kyle and his team have discovered you can make some lethal weapons with these bladelets.
This one looks particularly vicious, I think.
This is one interpretation of how those small back blades might have been mounted. The advantage to this would be that there's these barbs that would prevent the tip from pulling out immediately and would inflict a greater injury.